Alright everyone, welcome to week 4 of Finite Help. I'm Andrew Roosh with Roosh Tutoring, and today we're going to go over probability, balls, dice, and hamsters. So real quick, you guys have probably heard about probability and, what are the odds of whatever happening. Well, in reality, probability is the number of possible outcomes that fit a particular criteria over the number of possible outcomes in a sample space. So for example, you could be flipping a coin and, maybe flip a coin 10 times. Well, what's the probability that you get 3 heads, right? And there's all kinds of different ways you can get the 3 heads when you flip a coin 10 times, but, there's particular ways to solve that particular probability. I'm going to go through a few different examples here. So our first one, we have a bucket where there are 4 green balls, 4 red balls, and 5 blue balls. If I pick 2 balls at random, what's the probability that they are the same color? So first I'm going to look at the denominator. Okay, so how many different ways can I pick 2 balls from the bucket? Well, if I have 4 red, 4 green, and 5 blue, I have 13 total balls. So that means my combination of 13, I'm choosing 2 of these balls, right? So that is my number of ways I can pick 2 balls of any color, right? But now there's a particular condition that we want to achieve, right? We want to have 2 balls of the same color. So now we can either have 2 green balls, we can have 2 red balls, or we can have 5 blue balls that satisfy this condition, or 2 blue balls out of the 5 that satisfy this condition, right? So how many different ways can I select 2 green balls? Well, I can have a combination of 4, choose 2. Plus, I can have 2 red balls, right? Which is a combination of 4, choose 2 also. Or I can have 2 blue balls, right? And there are 5 blue balls to choose from, so there are how many different ways? And here I can solve out these combinations. If you remember, C of n r equals n factorial over r factorial times n minus r factorial. So this would equal 4 would be 4 times 3 divided by 2. That would be 6 plus 6 plus 10 divided by 13 times 12 divided by 2. That would be 78, I believe. Or I'm sorry, let me check that real quick. Yep, 78. So then I have 22 over 78. Of course, you can simplify this down to be 11 over 39. Great. So that's the probability that I pick 2 balls of the same color of any of these balls here. Now moving on, we have our hamster problem. So here we have 5 hamsters and 6 mice in a cage. Now if I want to pull out 3 rodents at random, what's the probability that I get more hamsters than mice? Now, again, we did combination in the last problem and kind of assumed it, but let's maybe take a look here. Does order matter when we're pulling out these hamsters? No, we're just pulling out a group of them and counting up what the totals are. So therefore, we are using combinations. So how many different ways can I pull out 3 hamsters in total? Well, there are 11 total rodents, right? I'm sorry, pull out 3 rodents. So we have combination of 11, 3, and then what satisfies this condition, right? Well, we want more hamsters than mice. So we can either have 3 hamsters and no mice, or 2 hamsters and 1 mouse, right? Any other way we'd split this, and we could have 2 mice and 1 hamster, but that wouldn't satisfy our condition here, right? Getting the more hamsters than mice. So we're going to have combination of 5 hamsters, and we're going to choose 3 of them, right? That's our 3 hamsters. Plus, we want our 2 hamsters and 1 mouse, which would be combination of 5, 2, times combination of 6, 1. Voila. So what's combination of 5, 3? Well, that would be, we went through that before. So this would be 10 plus, combination of 5, 2 is also 10, times 6. Divided by, 11 choose 3 is 11 times 10 times 9, divided by 3 times 2 times 1. That's 3. So that would be that'd be equal to 11 times 5 times 3 is equal to 165. So if we clean this up, we get 10 plus 10 times 6 is 60. So that's 70 divided by 165. And that's a probability of getting more hamsters than mice. Now our next problem is with regards to dice. So here, we're talking about, I'm rolling 2 6-sided dice. We're not playing Dungeons and Dragons or any of the weird games like that where they have the bigger dice. So with this regular dice, what's the probability that the sum of the numbers is greater than or equal to 9? Well, when you're dealing with dice, especially rolling 2 of them, I find this tool helpful. It's called a dice chart. And what we do is we have our 2 dice set up here, and you can add the results of the sums together. So here, if we had 1 plus 1 is 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8. Alrighty. And so you see here, I've added together all of the sums of the 2 dice, right? So 6 plus 6 is 12, and 6 plus 5 is 11, and so on and so forth. Now, what we can do is, the question they're asking is, what is the probability that the sum of the numbers is greater than or equal to 9? Well, with the probability, you have to have your denominator and numerator. So our denominator is the 6 times 6, right? There are 36 different results. Little squares here we can have, right? So we'll do 36 as our denominator. And then greater than or equal to 9, well, we start counting up. We have 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers that are greater than or equal to 9. So 10 over 36. So hopefully this gives you a little bit of understanding of probabilities and how to solve them. There's many other problems that can come up, but again, some of these have similarities. If you have any more questions or want to schedule a tutoring session, don't hesitate. Just text me or look me up on Facebook. It's Roosh Tutoring. Thank you for your time and good luck.